Okay, so sooner or later, I gotta do this NHT 2023 method exam too. Anyway, in my opinion, the overall difficulty of this paper, very balanced. There are a number of, you know, interesting questions on this paper, and I actually will adapt a different approach than before. So let's actually have a look at the section B, extended response questions. And I will start with the last question in the hope that we find it's not necessarily the last question, the hardest one. So question 5, 10 marks. Let f of x equals to 2 sine 3x plus 1. State the amplitude of f. Pretty easy. Amplitude is 2. And the range of this function is going to be the middle line subtracting the amplitude, the middle line add the amplitude. So basically, this is -1 to 3. Okay, now I will do part C1 and 2 together. Firstly, give the general solution for f of x equals to 0. And secondly, calculate the sum of solutions for f of x equals to 10, where x goes from -10 pi over 3 to -5 pi over 3. Right, 1 mark each. So on the calculator, what I would do first is I would define this function. F of x is assigned to 2 sine of 3x plus 1, okay? And then we can actually solve f of x equals to 0, comma x. And you will see there are two expressions. And this n1 is basically an integer without other domain restrictions. And then the sum of solutions between the given interval, we can actually do this. Zeros f of x, comma, x, and we put the given that, a little bar there, -10 pi over 3 less than or equal to x less than or equal to -5 pi over 3. The advantage of this command is that you can get all the solutions or the zeros in one curly bracket, which is a list. Then the question wants you to sum up all these solutions. Basically, I'm going to type SUM, sum, and drag this down. You get -10 pi, okay? So basically, you can just copy your screen for these two parts. Another 2 easy marks. So let me get back to my paper and show you what we're going to write. Okay, remember, general solutions, you have to specify your domain restrictions, like x equals to 12k or 12n, whichever letter you like, bracket times pi over 18, or x equals to 12k plus 7 times pi over 18. But don't forget to mention k is any integers, okay? And there's only 1 mark to part B. So I'm going to say sum of all solutions equals to -10 pi. Simple as that, okay? Now, turning over, we have another definite integral g of a, which is given by 0 to a f of x minus 1 dx for some a value between 0 to half pi. Okay, they also tell you directly the result of this definite integral is -2 over 3 cosine 3a minus 1. So we want to find the maximum value of g and the value of a for which this occurs, and the minimum value of g and the value of a for which this occurs. Basically, we can also get back to the CAS calculator, get the maximum and the minimum on the given domain. Now, here we define g of a equals to -2 over 3 times cosine of 3a minus 1. All right, and then f maximum, function max, you can access that from calculus, function maximum. We're looking for the maximum value for this function g of a. Variable is a from 0 to pi over 2. Okay, when a is pi over 3, we reach the maximum. So don't forget to sub in the a value and get the maximum value. Alternatively, we can just get f minimum. Copy everything and change it to f min. A equals to 0, which is in our domain on the left side, and then g of naught is naught. All right, so basically that's how you get another 4 easy marks, which is quite interesting. And let's go back to the main document we are working with and jot down these answers. Okay, find the value of a such that 1 over a times g of a equals to 1 over half pi minus a times the integral of a to half pi f of x minus 1 dx. Give your answer correct to 3 decimal places. Well, don't forget your domain restriction. A is between 0 to half pi. But notice another detail here. This letter a is in the denominator, which means your a cannot be equal to 0. Also, the pi over 2 minus a is also in the denominator, so a should not equal to half pi, okay? Therefore, we actually solving this equation on an open interval, so this is an implied condition. Let's switch back to the CAS calculator and use the solve button. Solve button control fraction g of a divided by a equals to 1 over pi over 2 minus a and integral a to pi over 2 f of x minus 1 dx, comma a, given that 0 less than a less than pi over 2. We can see the outputs are very interesting. 1 little e to the power minus 38. This is a very small number, technically 0. 10 to the power of minus 38. We ignore that. And also 1.57, I suspect this is a close approximation to the exact value half pi. So we also reject that, and we only take the middle value, correct to 3 decimal places, which is 0.144. Okay, finally, let h of a equals to 0 to a f of x minus k pi over 3 minus 1 dx. K is a greater than 0, and a is also between 0 to half pi. Given that h of a is 4 over 3, we want to give all values of k greater than 0. Just be aware, we want the values. Maybe we are looking for some general solutions. Be 100% aware of these situations when you are working with circular functions like sine, cosine, sometimes tangent. If they want you to find some unknown values of k, n, or whatever, you must be aware general solutions may arise. So we can actually get this integral equal to 4 over 3. Use the CAS calculator to simplify that and then do some analysis. Now, define h of a equals to shift integral 0 to a f of x minus k times pi over 3 minus 1 dx. Okay, so instead of typing solve first, I will actually type out the equation and get the CAS to simplify for us. So basically, we have this equation, minus 2 over 3 cosine something minus cosine something equals to 4 over 3. If we expand that, we may get the expressions easier to be observed. So you can see there is a 2 over 3, there is another 2 over 3, but with a minus in the front. If we want the whole thing to equal to 4 over 3, I would suggest, how about letting cosine term equals to 1 and this cosine term equal to, minus 1. So the minus 1 will compensate this minus sign, and then altogether, left-hand side equals to the right-hand side 4 over 3. So we actually have two simultaneous equations. Menu 3, 7, 1. We can find the two unknowns, a and k. So we'd like cosine k times pi equals to 1, and cosine 3a minus k times pi equals to minus 1. Don't forget the domain restriction. A is between 0 to pi over 2. Okay, so we can actually get some interesting outputs. But the question only wants us to find, for example, the k values. So instead of this n5, the parameter is all integers. I would say k must be 2n, and n must be positive integers, okay? Righty-ho. That's a lot of work for the final answer mark, but considering the position of this question part being the last one, ice on top of the cake, I would say this 1 mark is a fair one, okay? So I will tidy up everything and write down some key stages. 2 over 3 cosine k pi minus 2 over 3 cosine 3a minus k pi equals to 4 over 3. So we'd like this to be 1. We'd like this term to be minus 1. Actually, the only a value that satisfies the requirement, I suspect, would be pi over 3. That's the smallest one. And the k is actually 2n, where n must be all positive integers. So I'll just highlight this with red color. Okay. All right. So fairly easy. Last question is done. Okay. Let's shift back to the question 4. A bakery makes thousands of cupcakes during their morning shift. On average, 70% of the cupcakes are vanilla flavored. A large random sample of 100 cupcakes was inspected by the manager to calculate the proportion p hat that were vanilla flavored during the morning shift. P hat is a random variable representing the sample proportion. So the mean value of capital P hat is basically the population mean, and population mean comes from this phrase, on average, calculated based on large number of cupcakes, which is 0.7, okay? Maybe I should write 0.70, corrected two significant figures, but doesn't matter. You could also write this one as 7 out of 10 or 70%, preferably a decimal or fraction, and then calculate the standard deviation of p hat based on all sorts of assessment reports officially published by VCAA. You need to be aware of the rounding instructions. There is no rounding instruction. A common mistake of students is that they rounded this value further, and this is some sort of over-engagement error. No rounding instruction, exact only. So I would say substitute into the formula the standard deviation of p hat from your formula sheet. Last section, you just write 0.7 times 0.3 divided by the sample size, which is 100. and work out with your CAS calculator, you get, let's see, root 21 over 100, okay? If the sample size were 600 instead of 100, what changes, if any, would occur to the mean and standard deviation? What changes, if any? So if my p-value is 0.7, my m value is 600, so expected value of p hat 2. A second version will still be p-value 0.7. Make sure you comment on no changes or stay the same. But standard deviation p hat 2 is going to be root 0.7 times 0.3 over 600. Maybe you should recognize some third expressions here. 1 over root 6 times 0.7 times 0.3 divided by 100. Well, this bit is exactly the same thing as before. So basically, you could argue that 1 root 6 times standard deviation of p hat. So decrease, standard deviation decreased by factor of root 6. Or you could say dilated by factor of 1 over root 6, okay? Make sure you use correct phrases to describe any changes. Okay, what is the probability in a sample of 100 cupcakes that more than 66 and fewer than 72 of the cupcakes are vanilla flavored? Give your answer correct to 3 decimal places. So let's call this vanilla flavored. Number of vanilla flavored cupcakes is V. This is definitely a binomial distribution. N is 100. Probability of being vanilla flavored is 0.7. More than 66. This is a discrete binomial random variable. So you need to be aware of the inequality differences. I'd like more than 66. So I actually start from 67, V less than or equal to 71, because we can't take 72. And you could work that out using your binom CDF. So looking at a binom CDF, 100.7, 70, 67, 71. So the answer is 0.4024797, etc. 3 decimal places, 402, I suppose. Okay. During the afternoon shift, the bakery makes a batch of muffins. The number of muffins made per batch may be modeled by a normal distribution, X, with a mean of 69 and a standard deviation of 7. Oh, that's an interesting one. A number of muffins is actually a discrete random variable more appropriately, but now, okay, let's see. X is a normal distribution, 69, 7 squared. There is a real number A such that probability mu minus A less than or equal to X less than or equal to mu plus A is 0.64. Calculate A, give your answer correct to 3 decimal places. Okay. Now, I would say this is 69 minus A, and this upper bound is 69 plus A. Well, there are a couple of different approaches, but I think it is always helpful to draw the diagram. 69 is here. 69 minus A is here, and 69 plus A is here. In the middle, if we have the probability or area under this normal curve, 0.64. Then each side, according to symmetry, 0.32, okay? And 0.32. So this side, I'll use another color. That will be 0.18 and 0.18, okay? So altogether, normally if we are working with the inverse norm CDF to find the boundaries, on the TI calculator, we will always use the left tail. Left tail probability, X less than or equal to 69 plus A equals to 0.82, okay? Because we are excluding this part, 0.18 on the right tail. So use inverse norm. We find a Z value. Okay, just let me get the value. All right, remember, there is a formula linking the mean value, standard deviation, X value, and Z score. That is Z equals to X minus mu divided by sigma. So we have 0.915365 equals to 69 plus A, that is the X value, subtracting 69, dividing the standard deviation. And we can get our CAS calculator to do the job for us. So getting back to the CAS calculator, we can use inverse norm rather than the actual value here. 69 plus A minus A is A divided by 7, comma A. So the A value is, correct to 3 decimal places, 6.40755555, etc. So it's 6.408. Alternatively, well, CAS calculator syntax shouldn't be included as part of your solution process, but if you explain the process clearly, I think it should be fine. Let's say manual algebra solve. Norm CDF. 69 minus A, comma 69 plus A, comma 69, comma 7. In this command, we are actually pretending A is a known value. So we are pretending we are looking for a norm CDF probability and forcing it equal to 0.64, comma A. We are solving for this unknown A. Remember, A has to be a positive value in the scenario. So we put an extra domain restriction given A is greater than 0. Otherwise, CAS won't be able to solve it. So we can actually get a 6.40755. You can see there is a slight truncation error, but based on the required level of accuracy, I think it should be fine. 6.408. Yep, our answers matched. Okay, let's have a look at next few parts. A local delivery company claims that there is a 90% probability that each delivery it makes from the bakery will arrive on time or earlier. Well, very similar phrases to 2020 math method exam 2. I suppose, yeah, there was one similar question asking this sort of scenario, some deliveries arriving on time or not on time. Okay, assume that each delivery is independent of all other deliveries. Okay, so if you see this phrase, highly likely binomial. Find the probability that on a day in which the delivery company makes 20 deliveries, so N is 20, more than 15. So let's say delivery is a binomial. Number of deliveries D. Binomial N equals to 20, P equals to 0.9. Number of punctual deliveries, okay? So more than 15, that means greater than or equal to 16, but less than or equal to 20, because you can't exceed your upper bound or the maximum number of trials in each experiment. So another binomial CDF problem. Well, that is too easy, I suppose. Fingers crossed for the end of the year paper. 20, 0.9, 16 to 20. Okay, actually, yep. 0.9568255, etc. Let's round this to 3 decimal places. 0.957. Two marks. Okay, I think identifying the binomial distribution with correct parameters would be 1 mark, and the answer is another mark. All right. C. Question 3, 11 marks. Consider the graph of f of x equals to x to the power 3 minus ax, where a is a real number with its turning point, a and c as shown below. Okay, they provide you the turning point here and here. Find using calculus an expression for the shaded area in terms of a bounded by the function f and the horizontal axis on the graph above. Well, it's been a while not seeing these sort of phrases using algebra, using calculus, but okay, if they say using calculus, you need to show appropriate derivative or actually more than an integral. It's not like okay, here is the integral and you tell the assessors, hey, this is what my CAS calculator spat out. No good. You have to show the antiderivative process, okay? Okay, so the area, let's have a look. So I don't want to introduce the negative sign in front of my integral. So I would use the positive bit from minus root 8 to 8 to 0, okay? And double that area to get a total area. So 2 lots of minus root 8 to 0. Anti-deriving whatever we need to anti-derive. X cubed minus a times x. I don't think writing down this integral only will attract the first mark. So I think you should at least get your antiderivative, which is quite easy, like an year 11 exercise, in my opinion, in my modest opinion. Okay, now you need to show some substitutions. Before you substitute anything, I would say I'll take out a quarter, or actually I'll take out I'll bring these 2. So you're actually working with x to the power 4 over 2 minus ax squared. But you haven't evaluated this antiderivative yet. You need to substitute 0 minus 0. That's the upper bound substituted. The lower bound, root a minus to the power 4. That is a squared, which is, yep, that's just a squared, okay? Because minus root a squared and a squared again. So a, that's inside, squared. So a squared over 2 minus a times a. Yep, because minus root a squared is just a. So you actually get minus a over 2 minus a squared. You must simplify this to get a over 2 square units. Okay, let's just check with our CAS calculator whether our answer is correct. So we can actually insert another problem. Don't forget to put this multiplication sign whenever you see a letter, another letter in front of your variable, or another letter in front of your function, okay? 8 times x, and then 2 times the integral minus square root of a to 0, f of x dx, half a squared. Terrific. The turning points of graph of f are also the vertices of the rectangle ABCD as shown below. The line segment AC is the diagonal of the rectangle. So let's have a look. Calculate the area of rectangle ABCD when a equals to 4, and then explain why the value of a must be greater than 0 for the area of rectangle ABCD to be positive. Show that the area of the rectangle ABCD can be written in the form a over 3. Okay. So we can actually formulate this area. Area of rectangle is, this bit is a over 3. So this bit is root a over 3 as well. 2 times 4 over 3 under the square root. That's the width times the height. So the height, this bit is 2 times a over 3 to the power 3 over 2 times 2 times 2, 4 over 3, 3 over 2. Okay? It's just an exercise of substitution, formulation and substitution. But don't forget, you have the small elements with 2's. That's somewhere students are very easy, very likely to make mistakes. So we will use our, actually, we don't need to use our CAS calculator. 2 times 2 times 2, that's 8. Root 4 over 3, that's 4 over 3 times half. 4 over 3 to the power 3 halves. 8 times 4 over 3 to the power 2. That'll be 8 times 16 divided by 9. So this is 128 divided by 9 square units. Explain why the value of a must be greater than 0 for the area to be positive. So according to the diagram, root a over 3 is in fourth. X equals to root a over 3 is in the fourth quadrant. So this x value must be positive. Therefore, a must be greater than 0. Also, for these sort of explain questions, you have to be very careful. You need to include a sufficient level of details. Otherwise, if you miss the tiny bit detail, you probably won't get the mark. Also, y equals to 2a over 3, 3 over 2 must be greater than 0. For a positive area, a must be greater than 0. Okay, And show that the area of the rectangle ABCD can be written in the form 8 times A over 3 to the power 2. I think, what if the student did part D first, then coming back to the second part? Well, that's an interesting aspect because you can see if the student worked out with A of small a is 8 times A over 3 squared. How about A of 4? A times 4 over 3 squared. Exactly the same thing. 128 divided by 9. Well, that's an interesting one. So what I'm trying to do is we need to show the formulation like before, like in part B. But instead of working with a specific value of letter A, we are actually saying A of small a that's the width, and that is the height. The paper provided the students 3 lines. So you expect 1 line of formulation, 1 line of working. Combining these together, that will be A over 3 squared. And that's shown, okay? For show that questions, try not to skip steps or assume steps. Okay, find in terms of A an expression for the length of A to C. And F, find the x values of the points on the graph of F in terms of A, where the tangent to the graph of F is perpendicular to AC. So what I'm trying to do is, this graph is an odd function. If it's an odd function, not only we have f of minus x equals to minus f of x, but also we need to notice some symmetry, rotational symmetry about the origin. Okay, so I would directly say, okay, between these 2 points that we work out the distance, but this line segment also goes through the origin 0, 0. So we can actually work out the distance from any one of the turning point to the origin and then double the distance, okay? BAC is going to be 2 lots of distance OC. That'll be 2 lots of root A over 3 minus 0 squared plus 2 lots of, actually minus 2 lots of A over 3, 3 over 2, subtract 0 squared, okay? So that's one line of, that's one line of formulation, and we probably will get our CAS calculator to figure out what's happening. In this case, I actually want to be lazy. I'm using a command of norm, square root of A minus 3, A over 3 minus 0, comma, minus 2, bracket A over 3 to the power 3 over 2, minus 0. Oh, the CAS calculator also spit out another interesting expression because the CAS can't tell if A is real number or complex number. So I'll put a domain restriction A greater than 0. Okay, so that is an expression you want to jot down. I mean, there are other equivalent forms, but if you typed everything correctly into your CAS calculator, you won't be far away from your correct answer. Okay, and let's have a look at the last part of this question 3. Find the x values of the points on the graph of F in terms of A, where the tangent of F is perpendicular to AC. So the gradient of AC is equal to the gradient of OC, in my opinion. Just be very careful when you formulate your equations or expressions. I mean, this point can be written as that, okay? So basically, y value subtract 0, x value subtract 0. Fairly straightforward. You don't need to put an extra negative here because this, when evaluated, will give you a negative, okay? All right. And the gradient of tangent on the graph of f is f dash of x. Because they are perpendicular lines, you can say f dash of x times the gradient is -1, okay? All you want to do next is solving this equation by your CAS calculator. Going back to your CAS calculator, see how we go. Solve button. The derivative is given by ddx f of x times fraction. Fraction has f of root a over 3 divided by square root of a over 3, comma x. Oh, sorry, I forgot to type equal to -1. Gradient multiplied together equals -1. And you can see the question has the phrase, the x values. So there are actually two values, x equals to plus or minus that expression, okay? Don't forget to drag it along the way in your CAS calculator and make sure you see all outputs. The expression or the condition after the phrase and is just a domain restriction, I suppose, which is not required as part of the final answer. But if you state that correctly, it should be okay. Plus or minus root 6 2a squared plus 3 divided by 6 root a. X values. Okay. Let's have a look at second question. Do you like drinking coffee? Well, the amount of caffeine present in Kim's body after they drink espresso coffee can be modeled mathematically. Students suggest that the amount of coffee C milligrams in Kim's body T hours after consuming espresso coffee can be modeled by the function Ct equals to 65 e to the power minus t over 8. How much caffeine will be present in Kim's body 2 hours after they consume espresso? Give your answer in milligrams, correct to 1 decimal place. How long will it take for the amount of caffeine in Kim's body to reach 10 milligrams after drinking an espresso? At what rate is the amount of caffeine in Kim's body decaying 4 hours after they drink an espresso? Okay, right, ABC. In fact, I will insert another problem and define C1 of t equals to 65 exponential. Exponential is the abbreviation of exponential function, okay? Then in the bracket, you just type the exponent. Okay, so C1 of 2. Give your answer correct to 1 decimal place. So the answer should be 50.6 milligrams, okay? And the second part, how long will it take for the amount of caffeine to reach 10 milligrams? There are 2 marks. So I will solve an equation equal to 10, comma t. This is the exact t value. And this is the decimal answer, but you have to read the question very, very, very carefully. It was tricky to see if your answer in hours and minutes. In fact, the question at the start defined t as hours. So you want to get this decimal part, 0.97 something, multiplied by 60. So it is correct to the nearest minute using the normal rounding. That is roughly 58 minutes. But there is another argument around that saying, okay, it's not enough if we just take 14 hours and 58 minutes. It's not enough to get closer enough to 10 milligrams. But I would just suggest use normal rounding, okay, in that occasion. So the answer is 14 hours and 58 minutes, okay? So this part requires you to work with two stages, okay? Firstly, you need to equate your C of t to 10, and you get an exact answer, 8 log E 13 over 2. I mean, you could also write this one as 14.974417, etc. But that's in hours. Because the unit is different. You have to answer your question quoting hours and minutes. So that's 14 hours and 58 minutes. Which means if you just quoted your answer 14.97, I suspect you can't get full marks with this part. At what rate is the amount of caffeine in Kim's body decaying? Okay, now paraphrasing, decreasing, okay? The rate decreasing. So the rate of change is a negative value, but when you answer this question, you should get rid of that negative, saying it is decreasing at a rate, then put the absolute value around that negative value, okay? This question is looking for C dash of t, then substituting 4, okay? So your CAS calculator is able to do that. I'm just about to show you. You can see the CAS calculator gives you a negative answer, but you should answer the question like 65 over 8 root E. That's the rate of decrease when t equals to 4. Okay, so it's not difficult. It's just a matter of reading the question carefully. Kim consumes another espresso coffee 4 hours after consuming the first. When t is greater than or equal to 4, the function C2 strictly increasing, strictly decreasing, or neither. Okay, if you can plot this function on your CAS calculator, it's roughly like that. Two parts. Both parts are strictly decreasing, okay? So we just say strictly decreasing. show that the function C2 is not continuous for t greater than 0. You can see there is a critical point at t equals to 4. You need to discuss when t equals to 4, what happens to both parts, both components in this hybrid function. So when t approaches to 4 from left, 4 minus, it's not an anion, okay? Or 4 plus, it's not a cation. It's 4 from the left side, okay? This is particularly important to those who are familiar with chemistry notations. And also you need to discuss when t is approaching to the right side of the number 4, okay? C2 of t is approaching to 65 e to the power of minus half. And when you sub the 4 in here, also when you can sub the 4 in t here, C2 of t for t approaching to 4 plus, that is 65, 1 minus e, 1 minus root e, e to the power of minus 1 over 2. From this point on, you can argue that the two y values or c values are different. Therefore, it's discontinuous or not continuous. But to be more rigorous, I would get you to simplify 1 minus e, 1 minus root e is actually 1 minus root e, 1 plus root e divided by 1 minus root e. So it can be cancelled down further. 65 1 plus root e, e to the power of minus half, which is obviously not equal to 65 e minus half. Okay? Again, it is not harmful to include a more level of rigorous mathematics. Therefore, C2 is not continuous or t greater than 0 because there is a point of discontinuity. Okay, using C to find the maximum amount of active caffeine in Kim's body and the time at which this level was reached, give the maximum amount of caffeine in milligrams correct to 1 decimal place. So if you plotted these two graphs on your CAS calculator, you can see here is a maximum, but not a turning point. So it doesn't work if you take the derivative and equal to 0 to find a stationary point, okay? So this is another exercise of using graphical or symbolical representation. And these are more successful approaches. When t equals to 4 hours from graph, C max equals to 65, which is exactly this thing. 1 plus root e, e to the power half. And we can evaluate these to 1 decimal place in milligrams. The CAS calculator would be able to do that. So let me just get my CAS to do this. So the answer is 104.4 milligrams. 104.424, etc., etc. Okay. Okay, find the derivative C2-t, giving your answer as a hybrid function, and that includes the relevant domains 2 marks. Fair 2 marks. So what I'm trying to do with my CAS calculator, well, you can define C2 of t equals to hybrid function template, let's say 65 exponential minus t over 8 for 0 less than or equal to t less than 4. And then 65 exponential minus t over 8. Don't forget you need to multiply a bracket. You could type out 1 minus e over 1 minus root e, but we have done some simplifying work. So we just type 1 plus square root of e. And that is for t greater than or equal to 4. Okay, then we can just take the derivative with respect to t. Okay, so you just write down whatever you obtain from a CAS calculator, but do notice the critical points and the endpoints. Once you derive the whole function, they are all exclusive. Okay, so let's carefully write this down. Two marks. I think the derivative hybrid function, this line 1 mark, this line 1 mark, or both of these expressions correct 1 mark, and these two domains fully correct 1 mark. I mean, there are separate ways, multiple ways to award the 2 marks, but again, there is no half marks. It's not like half, 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 half. Has to be marks have to be awarded based on a whole number basis. Okay. Using the derivative c dash t to find the times during which the amount of active caffeine is decreasing by at least 8. That means you have to use c2 dash t less than or equal to -8. Okay. So this is actually a very tricky one. Alternatively, you could just draw the derivative graphs, something like that. And you can find, okay, this is c dash t equals to -8. Even lower than -8, the horizontal line, okay? Alternatively, you could use the absolute value of c2 dash t greater than or equal to 8, which should yield the same thing. So that less than or equal to -8, comma t. Okay, that is one set of values. Alternatively, you could go for absolute value of the derivative, but this time it's greater than or equal to 8. Yep, the same answer. So just carefully copy the screen in interval notation. Okay, I'll show you what I'm going to write down. These two open brackets inherited the point of discontinuity on the gradient graph. And these two closed brackets comes from these two intersection values, okay? Right, so this one is a very interesting question. Needs a bit of thinking. And I would say question 2 is actually the most interesting one. Need a bit TLC, tender love and care, extra, okay? Right, first question. Oh, starting with a quadratic function, excellent. Express the rule of g in the form g of x equals to ax squared plus bx plus c. Well, to be honest, you can just button press. You can say g of x is x squared plus 4x plus 4 minus 1, which is plus 3, okay? Expanded form. Use your cast to expand, that's fine. So the function can also be written in the form g of x, x minus p, x minus q. Give the values of p and q. In fact, it's the opposite. Because when you factorize this g of x, it's x plus 3 times x plus 1. So the p value should be minus 3, q value should be minus 1. Or p equals to minus 1, q equals to minus 3. But there is no need to specify both cases. One case should be enough, okay? Just different orders. Find the value of k for which the graph of that passes through the origin. Okay, so 0, 0 will lie on y equals to g of x plus k. So 0 equals to g of 0 plus k, which means k plus 3 equals to 0, and k is minus 3. Ooh, fantastic. An excellent year 11 method question. Finally, using algebra, find the values of these such that the graph of y equals to gx minus d will pass through the origin. Okay. So what I'm trying to do is g of x minus d equals to x minus d plus 3, x minus d plus 1. So basically, you need to show some algebra like substitution, formulation, whatsoever. Use g of 0 minus d equals to 0. Then you should have 3 minus d, 1 minus d equals to 0. Putting a 0 here and here. So d equals to 3, d equals to 1. I mean, some formulation with by-hand algebra is expected, and then both answers. That's why the question says find the values of d, and there is no other restrictions on the parameter d, so you should take both answers. Describe the transformation from the graph of g of x to the graph of g3x. So apparently it's a dilation factor of 1/3 from the vertical or y-axis. Okay, it's not a dilation factor of 3. Okay, because you want to work with g of x divided by 1/3. Okay, right. Let h be mx plus n. M and n are real numbers. Find the value of m such that the graph of some function gx plus hx has a turning point on the y-axis. Turning point on the y-axis, well, let's have a look. We actually insert another problem. We define g of x as it was, and define h of x equals to m times x plus n. Okay, let's define y1 of x equals to gx plus hx. So what does y1 of x look like? Looks like this. So it's still a quadratic function. We may use the command complete square minus 3, 5. Because we know this is a quadratic, there is only one turning point. Once we write this thing, in the turning point form or complete square form, we can actually locate where the turning point would be. Okay, so in that sense, I would say this must be 0, this bit. Okay, so m is minus 4 apparently. Alternatively, you may want to solve the derivative of that equal to 0 and equate the x expression to 0 involving the letter m. Okay, so that is another approach. So let me just get back to the working document and write down some important steps. Okay. So x plus m plus 4 divided by 2 squared plus, actually, let's write plus n minus m squared divided by 4 minus 2m minus 1, okay? So turning point at x equals to 0 means m plus 4. Actually, minus m plus 4 because that's in the form x minus h squared plus k, okay? Equals to 0. So m equals to minus 4. That's it. As long as you are applying a valid method and get the answer, it should be fine. There is no specific prescriptive method as long as it's valid. But then find n in terms of m such that the graph of the sum function has a turning point on the y-axis. So think about a turning point for hk. If it's on the x-axis, this value has to be 0, okay? So the turning point, we can read off the turning point from the previous working. Minus m plus 4 divided by 2. M minus m squared divided by 4 minus 2m minus 1. So we want this whole thing equals to 0. Set y coordinate equal to 0. We actually see n equals to m squared divided by 4 plus 2m plus 1. Just push all this bit to the other side. Okay? All right, find two pairs of the values for m and n such that the graph of the product function gx times hx. Oh, interesting. So this is y2 of x equals to, let's say, x plus 3, x plus 1. That is the gx bit. hx is mx plus n. Another question you need to think about is this function necessarily a cubic? I mean, if it's cubic, mn, actually I should say m cannot be 0. All right, then we have a repeated factor. We could have either m of x plus n over m can be matched to x plus 3. So n over m equals to 3. Therefore, n equals to 3m. So we can pick a specific value of m. So one possible pair is, let's say, n equals to 3, m equals to 1, okay? Or, let's say, m times x plus n over m match x plus 1. So n over m equals to 1. M equals to n equals to 1. So that's the second pair. If it's reduced to quadratic, definitely you don't want the whole thing to be 0. Otherwise, that would be infinitely many solutions, okay? I mean, if this is 0, the whole thing equals to 0, y2 of x is always 0, then it's invalid. So we can say m equals to 0, n equals to 1. The whole thing reduces to a quadratic, which has two x-intercept at minus 3 and minus 1, okay? So there are so many different answers. That's why they say two pairs. Find two pairs rather than find all pairs or all the possible values, okay? As long as you get two possible, correct possible pairs, it should be okay, I think. Finally, find the coordinates of the turning point of the graph y equals to g h of x. Give me your answer in terms of m and n. So this is a composite function. Well, define y3 of x equals to g of h of x. Okay, menu 371. Y equals to y3 of x. And derivative y3 of x equals to 0. Okay, now all right, probably need to look a bit further. Complete square y3 of x comma x. Okay, so that's the turning point form. So we have to assume m is not 0 in this case. Otherwise, it won't give any turning points. If only the question also specified m is non-zero. But we just play with what in front of us. Don't forget the negative sign in the bracket. Fairly important. Okay, so if m is not equal to 0, this is the point, the turning point with their coordinates. Okay, so I've done all 5 extended response questions. And let's have a brief look at the multi-choice questions, okay? Okay, the first question, the period is very simple. 2 pi over n, which is 2 pi over 2. And that's pi. Choose boy. Second one, instantaneous rate of change. So it's the derivative value when t equals to 1. You can use your CAS calculator to get f dash of 1, which gives you 50. This is also very simple. Question 3, that's the only one I'm not entirely sure. So the question provides you, let's say, a semicircle. And notice that at the two endpoints, the derivative are undefined. So this is -3, this is 1, okay? We want to find a strictly decreasing interval. I mean, the turning point is definitely here at -1. So it's just a matter of using f dash of x less than or equal to 0 or f dash of x less than 0, okay? But the gradient is undefined at that point. If we follow the first one, we get a domain of -1 to 1, open bracket. If we follow the second definition, we will have x from -1 to 1, open brackets, both open brackets. But if we think about the definition, fx2 minus fx1 is less than 0 for x2 greater than x1, then we could also say over this interval, any x1 and x2 will satisfy. So it's just a matter of choosing between B and D, and to be a more comprehensive set of the x values. Option D could be the most comprehensive answer. So please refer to the official NHT exam report, okay? So, question 4. Consider the polynomial equation f of x equals to x to the power n minus px plus 1. N is a positive whole number larger than 0. the highest value of n from the options below for which the graph y equals to f of x has exactly one intercept, one x-intercept. So I would choose option E, okay? Firstly, if we try the highest value up to 7, let's say n equals to 7, you can plot this graph on your CAS calculator, and it looks like the graph is always increasing, okay? Strictly increasing, no zero gradient. That's why the 7-degree polynomial will only intercept the x-axis once, okay? So basically, I would say option E, satisfy the intention of the question. Question 5, the value of EX, very simple. Multiply the X and the probabilities and add them up. So 0 plus 0.4 plus 0.6 plus 0.3, 1.3. You can see we can get through the first 5 multi-choice questions fairly easily. And the next thing, the range. Notice that for one complete period of the tangent graph, we have 2 adjacent asymptotes, vertical asymptotes. And the period is pi over 2, which is, half, okay? Actually, sorry, not half, 2. Bear with me. So x equals to 1, x equals to minus 1 will be the closest 2 vertical asymptotes in the middle. From 0 to half, it is strictly increasing. Half is here. So the y value is going from 0 to, let's say, 2. Okay? 0 to 2. When you sub that in, you should have f of half equals to 2 tangent pi over 4. That's just 2. Okay? Question 7. Well, you need to play with the 2 given integrals and manipulate to get minus 2 to 1. So basically, look at the, let's say, the largest one, okay? The integral with the longest terminal distance, okay? From minus 2 to 5, that's the longest distance. So I would say minus 2 to 5, f of x dx. We start with that, and then split that integral. Notice the different value 1 here, so I will split it as minus 2 to 1, f of x dx, plus 1 to 5, f of x dx. Once you split the largest integral into 2 pieces, this bit is 3, this bit is unknown, and the last piece is a negative value, which is minus 2. So rearrange that to another side. This integral will equal to 5. Okay. The weight of apples that have been picked from an farm are normally distributed with a mean of 182 grams and a standard deviation of 10 grams. 25% of the apples are not heavy enough to be sold to supermarket. Normal distribution, 182 grams. Standard deviation is 10. That's mu value. And 25, the lowest 25% will be rejected, okay? So the area under this bit is 0.25. So we can actually find this little x using inverse norm CDF. You can use your CAS, inverse norm CDF. The area is 0.25, mean value 182, and the standard deviation is 10. So you should get the boundary 175 to 551. Correct to the rounded to the nearest integer. That would be 175, okay? This is definitely closer to 175 rather than 177. That's why we choose A. Question 9. What I would suggest is you sketch a graph, okay? You sketch a graph. So it is important to sketch the graph and identify, okay, where the locations of the x-intercept. So you can find -1, 0, and 2. After you plotted this graph on your CAS calculator, you can write out 2 integrals your CAS calculator, -1 to 0, x3 minus x2 minus 2x dx. Notice that for the other chunk, this chunk has a negative sign area, so you need to put a negative in front. -0 to 2, that makes the integral positive, which evaluates the size of the area. Just be aware of that, okay? Using your CAS to evaluate this will give you 37 out of 12. Alternatively, you could also go from -1 to 2, absolute value, x cubed minus x squared minus 2x dx, and then press Control Enter to get a decimal approximation, and then compare the available options with your decimal approximation. Option C will give you the same decimal approximation. So that is question 9. Okay, 5 fair 6-sided dice, fair dice. So n equals to 5. That's how many experiments you are running. 6-sided dice. The outcome for each of the dice rolls is independent of the outcome for any of the other dice rolls. What is the probability of an odd number landing face up? Okay, so we have 1, 2, 3, 4, 5, 6. Odd number, 1, 3, 5. So 3 out of 6 faces, that's half. So P equals to half. Basically, we want exactly 3 dice to have the odd number facing up. So we are actually looking for x equals to 3. So 5 choose 3 times half to the power of 3, half squared. You can use your CAS calculator to get 0.3125, or more efficiently, you should use binom PDF. This is a binomial PDF function. 5, 0.5, and 3. Okay? Option B. Question 11 is an interesting one, because you don't know what g of x is and what e to the power g of 2x is, but you can apply both product and quotient. So basically, you are looking for du dx times v plus dv dx times u. So what is du dx? That's just g dash of x times v e to the power g2x plus dv dx. This is where you need to use chain rule. So derivative of the exponent is 2g dash 2x times the derivative of the outside, which is g of 2x. Don't forget to multiply u here, which is g of x. So basically, you can take out g e to the power g2x times g dash of x plus g of x with a 2 here times g dash of 2x. Okay, so basically, I would say option D is the correct answer. Okay, the graph of y equals to f of x is shown below. Notice that this is most likely a rectangular hyperbola, quadrant 2 and 4. So negative leading coefficient. I would say y equals to -1, x minus 1 plus 1. Okay, y equals to 1 here, x equals to 1 here. It's not here and here, so make sure you put a negative. Okay, now we want to find the derivative. The derivative dy dx is simply -1 times -1 divided by x minus 1 squared plus 0. So it's 1 over x minus 1 squared. This is trunkers, positive trunkers. So option C will be the most appropriate one. And another interesting thing is option A. Well, the correct answer for this one is option C. But when would we choose option A? Well, that would be the integration of that function, okay? If you antiderive this function, you can get a graph of option A. So just be aware of different phrasing. The reason why I'm saying that is because it's also common to see the graph of y equals to f dash of x is shown below. Then they are looking for f of x. In that instance, you will choose option A. Okay. Question 13 is Interesting one. You need to sketch this graph and then identify where the tangent line, which passes through the origin, will cut the x-axis. I'd like to use this command. Solve 0 equals to tangent line. Bracket. Natural log of 2x times x minus 2, bracket, x comma a. And we find a. Given x equals to 0. This letter a is our, dummy, a dummy variable. When we are using this dummy variable, we are trying to find the tangential point, x value, which is represented by a, okay? And then once we get the a value, we can go back and figure out the equation of tangent and then find the x-intercept. So that is a combined approach. Alternatively, you could also sketch the graph on your CAS calculator. Okay, so this is a value, this is 0, 0. And you could also get, for example, the derivative function at a point A, equate that gradient to the gradient of these 2 points, a of f of a. Let's call this f of x. So I can show you how this can be done on your CAS calculator. Plot a graph to double check. Okay, and yep, we're trying to get some sort of a tangent line like this. Let me just use my geometry button. Something like that, okay? So let's do it algebraically with a CAS. Solve button. Derivative at a particular value a equals to